You guys are good? Yeah? Okay. All right, so we're going to talk about the probability of multiple events. So basically doing one thing and then doing another thing. All right? Or maybe even doing a bunch of things in a row together, okay? So in order to find the probability of two events occurring together, the first thing you got to figure out is determine whether or not the events have an effect on one another, right? That makes sense, right? So we have these words that we use in mathematics to describe this. So the options are either yes, they're going to affect each other, or no, they're not going to affect each other, right? If the answer is yes, they do have an effect on one another, then the word that we use to describe them would be they are dependent events. And that makes sense, right? Well, right, if one event has an effect on the other, then one event depends on the other one, so that's a dependent event. So what do you think your guess would be for the word that we would use to describe where two events do not have an effect on each other? Yeah, the events are independent of one another, right? They are independent of one another. Okay? So first of all, that's what we have to decide, whether or not the events are either dependent or independent. That will help us to determine how we proceed forward, okay? So for box number 2, or second idea is, I just have a couple of examples, and I just want us to talk about them right now, okay? So we can define, as a class, let's just talk about whether or not we would think that these events would be independent or dependent, and we'll just talk about it, okay? There's 3 examples here. So for 2A, you're going to roll a number on a dice, and then you're going to spin a spinner. So there's 2 different events, right? The first event is rolling a number, the second event is spinning a spinner. What do you guys think? Would that be independent, or would those 2 events be dependent? Those would be independent events. Why do you say that? Yeah, because the number on the dice has no effect of what happens on the spinner, maybe the spinner's colors. So I would definitely say that these events are independent. I want to use the purple, I think. Okay, so these would be independent because one does not affect the other. So far, so good. Pretty straightforward. Everyone cool with that part? Okay. Here's another example. I already wrote it out for you. Let's just talk about it. I'll go there in case you're looking. You're gonna pick a card from the 52 card deck, right? Then, without replacement, you're going to pick another card from the same exact deck. So, flow and dependent. What is it about this that you would say that this is a dependent event? Yeah, there's one less card. So this would be dependent, right? So you can see why I didn't want to have you guys write down the examples when we can just sort of talk about them and understand. Is everyone on the same page so far with me? Yeah, it's good. Everybody's good. Brian's good. Cole's good. All right, let's do part C. Let's look about this one. If you select a coin from your pocket, all right, and then you replace the coin, then you select another coin. So you have 2 different events, right? Yeah, Rachel says this would be independent. I would agree. Why would you say this was independent? Yeah, right. Because for the second event, I reset the coins, right? So this one would be independent. Independent. Okay. All right. So the way that we move on is we want to compute the probability of 2 events if they are independent from one another. All right? If they're independent from one another. So basically, we want to first start out by talking about, okay, what would it take for us to understand how to compute the probability of A and event B happening together if they are independent events, okay? So here's a theorem that I have for you. It's an important one. We'll write this down. It's going to say this. If A and B are independent events, okay, so that means that they do not have an effect on one another. We just sort of talked about that. Then, so there's the if statement, then the then statement. It's an if-then statement for you. Then the probability that A and B occurs together is simply the probability of A multiplied with the probability of B. Okay? So all we have to do is multiply their individual events together. this should look a lot like what principle? Yeah, the fundamental counting principle, right? The fundamental counting principle. So I like to tell my students that the word and, when you see the word and, it implies multiplication. So when you see the word and in probability questions, you are more than likely going to be multiplying something at the end of it, okay? Go through the process with you. Okay, I like this question a lot. It says the probability that a car part will pass inspection is 93%. 93% that it will pass. I'm interested in finding out the probability that the next 5 car parts I inspect actually all pass together. Okay? So I have one person who says 70% back there, all right? Well, first of all, do you guys feel a little like, when I read probability problems, I always have to read them twice because they're kind of, they don't know, it's kind of hard to know which direction to go, right? Okay? Okay, so every time a car part is inspected, there's a 93% chance it's going to pass. I want to know the probability that the next 5 car parts will all pass together, okay? All right, so I kind of like to set this up as multiple events, right? The thing that I know, that the probability of a pass, the probability of getting a pass is 93%. So if I write that as a fraction, it's 93 out of 100. Is that fair enough to say? All right, so that's one event, right? And what am I interested in? I'm interested in the next 5 events, right? Here are my next 5 events. And I want them all to be a pass. Well, that's just 93 out of 100. 93 out of 100 for the second car part, 93 out of 100 for my third car part, 93 out of 100 for my fourth, and similarly 93 out of 100 for my fifth. And I am multiplying all of these together because they are independent events, right? The inspection on one car part has nothing to do with the inspection on a different car part. So therefore they're independent events. And if I know the probability of a pass is 93 hundredths, what do? Well, there's an easier way to write this. It's just 93 out of 100 to what exponent? Yeah, to the 5th, right? We're clever enough to be able to write that down. All right, so in your calculators, go ahead and calculate. This is approximately, when I did it, I got 69.6%. Pretty close to your 70. Is that what you did? You do the same thing? Yeah, pretty close, right? You guys ever go to the picnic? Who's ever been to a family picnic before? Only 3 of you? I've been on a family picnic before. They're fun. They're okay. All right. So here is the scenario. Okay, you are on the swing set, swinging back and forth, and it's a wonderful day, and you're having a great time. And your little niece or nephew comes up to you and says, "Hey, do you want a snack?" And you say, "Yes, I do want a snack. Go get me some snacks." You don't tell them exactly what. Okay. Well, there's a cooler. In the cooler, there's a cooler full of drinks. All right. Inside that cooler, there's 10 diet drinks, 5 regular drinks. All right. And then there is a bag of cookies. Love the bag of cookies. All right. All right. There are 8 fat-free cookies and there are 12 regular cookies. Okay. You are in training for a half marathon, so you want to figure out what is the probability that my niece is going to come back and give me a diet drink and a fat-free cookie. That's what you're wondering. As they run away, you're like, I wonder what that probability is going to be. All right? So, are the events independent or dependent, first of all? Why do you say independent, everybody? Right, Mia, exactly. One does not affect the other, right? One does not affect the other. Okay. So, then that's going to be the probability of getting a diet, right, is going to be what? What's my probability of getting a diet? Well, what's my fraction? We'll say my fraction. Yeah, it's 10 out of 15, right? Now, how do we compute, where did we get the 10 out of 15 from? There's 10 diet drinks, there's 15 in the sample space, right? That's all the ways I could do it, right? Okay, it's 15 total. All right, what's the probability of getting a fat-free cookie? Yeah, that would be 8 out of 20, right? Because there's 8 of them, there's a grand total of 20. Okay, well, according to my theorem, I'm supposed to multiply these together. So 10 out of 15 multiplied by 8/20ths That gives me what? What'd you guys come up with? What'd you get? Flo, what'd you get in the back, buddy? 26.6%? Okay, I'm with you. 26. Can someone else verify that's exactly right? 26.6%? It is? Could you leave it as a fraction? Would that be alright too? That would be alright too. So you don't have, is that a very good probability or not a good probability? Would you take that bet? Yeah. Okay. How would you, how would the question change if I wanted, like a diet and a regular cookie? What would it be? I just switch it around, right? No big deal. All right, not a big deal. All right. Before we move on and to talk about the or, we have to talk about this phrase called mutually exclusive events. Has anyone ever heard this phrase before? One person, two people, two and a third, 2.5. Okay. So what does mutually exclusive events mean? Yeah, Rachel, what do you think? Yeah, you're on the right track. Exactly. So but we say this: when two events cannot happen, cannot occur at the same time. Okay? At the same time. That's what we mean to say that two events are mutually exclusive. They cannot occur at the same time. If this is a case, then we define those events as mutually exclusive events, okay? So it's imperative to see the implication of this statement. The implication of this statement says that, okay, then the probability of A and B must be what if they are mutually exclusive? Yes, I see a symbol for 0 in the back of the room. That's right. That's what that means, okay? If A and B are two events that are defined as mutually exclusive, well then they are two events that cannot happen together at the same time. If they can't happen together at the same time, then their probability of A and B has to be 0. Is that fair enough to say? You guys with me so far on that part? Okay, great. So that's what it means to be mutually exclusive. Let me give you some examples of mutually exclusive event. Example number 1, okay? You're going to pick a card. What's the probability that that card is red and a club? That's 0. Why? Why would we classify this as mutually exclusive? Huh? Because clubs are black, right? So it is impossible to pick one card and have it be red and a club at the same time. They're mutually exclusive. What's that? Yeah, unless it's red on the back. Yeah, I meant like of the spade, right? Do you have what are the four suits? We have hearts, diamonds, spade, and club, right? Hearts and diamonds are always red. Spade and clubs are always black. So it's impossible to get a... So clubs can never be red. So that's why these are mutually exclusive. Okay, how about this one? If I were to roll a die, right? What's the probability of getting a 2 and a 3 if I'm only rolling one die? It's 0, right? They can't happen together. It's impossible unless they, like, let's get stuck in a crack or something and it's on its edge, but then that really wouldn't be it, okay? All right. Here's an example of something that's not mutually exclusive, right? If I'm going to roll a die, what's the probability of getting an even and a multiple of 3? Is that possible to happen? That can happen, right? So these are not mutually exclusive events because they can occur at the same time. Do you understand that phrase now a little better? You guys with me on that? Yeah? Okay. Okay. Now we get to talk about one or the other of two events. Okay? It's an if-then statement. Or actually it's only a part if-then. So if I am interested in computing the probability of A or B, then I'm allowed to say that, okay, it has to be the probability of A plus the probability of B, but I need to subtract the probability that they happen together. Probability of A and B. Why would I need to subtract the probability that they happen together? Yeah, P and B. Why do I have to subtract that part? Yeah. Yeah, if they can happen together, meaning that they're not mutually exclusive, if they can happen together, then I would be double counting in the first two slots of probability of A and probability of B. I would be double counting. I'll show you an example of that, right? Now, if... Oh, this should be an A, sorry. Thanks. Sorry, guys. There you go. These are events. These are events.
That can happen.
Yeah, this is the probability of A or B if they are not mutually exclusive,
They
right?
can be at the same time.
Yeah, but look what happens. Look what happens to my formula if A and B, this should be a D, sorry. If A and B are mutually exclusive, what happens to my formula then? Then I get this. The probability of A or B is just equal to the probability of A plus the probability of B minus 0, right? If they're mutually exclusive. And I get some claps in the background. That's awesome. Why is there a 0 down there, right? Because if they're mutually exclusive, then the probability of having them occur together is 0. And it's worth talking about that. Okay? Yeah, if A and B are mutually exclusive, then I get a 0 on the back end of that.
I'm confused because you gave us two. So you gave us one to compare the probability of A.
All right, let's explore this OR thing a little bit more because I think it will clear up your question, all right? So I have this dish over here, and this dish has a couple of pictures on it, okay? Or I have like little foam figures, okay? I have a yellow triangle. I have an orange circle. I have a red circle. I have some green circles. I have some squares, okay? So here's the question I have, right? You're gonna close your eyes. Suppose you close your eyes and you grab an object from the dish, okay? What's the probability that the object will be round or green?
Oh, so just
See what's going on here? Round or green. Okay. All right, so
but it's mutually exclusive.
we're going to get there. We're going to get there, okay? Here we go. Okay, the probability of round or green. That's what I'm interested in. That's what the question is asking me, right? It's going to be the probability of round, okay, plus the probability of green minus the probability of round and green. Because that is repeating. Very good. It's repeating. I should actually use the word and here. I'm going to show you. This? Okay, so here we go. What's the probability of a round object being chosen there? Well, rounds are 1, 2, 3, 4. I got 5 out of how many? I got 5. I got 5 out of 6, or 5 out of 9, right? Okay. Plus, what's the probability of the green ones? I got 1, 2. I got 3 out of 9, right? You guys go with that part? Okay, now I have to subtract off how many are round and green. Well, let's see here. Round and green. That would be this person here and this person over there. Those are round and green, right? So that'd be what? 2 out of 9. Okay, so now I need to compute all this. So my common denominator is all there. So 5 and 3 is 8. 8 minus 2 is 6. I'm getting 6 out of 9. What would that be? There you go. All right, here we go. Let's figure out. We're going to roll probability of odd or prime. So here we go.
2.
Whoa. Okay, here we go. The probability of odd, right? We want odd or prime. Okay, here we go. Well, the probability of, well, what's that going to equal? It's going to equal the probability of odd plus the probability of prime, right? Minus the probability of odd and prime. I always run out of room on this side. There we go. Okay, so I'm going to use that right to my advantage right there. Okay, so here we go. What's the probability of getting an odd one? Well, what are the odds? The odds are 1, 3, and 5, right? So how many is that total? So that's 3 out of 6, okay? So far so good? Okay, what's the probability of getting an prime? Well, let's see here. What are the prime ones? They are 2, 3, and then 5, right? All right. So That's also 3 out of 6, right? All right. Now, what's the probability of... no, 1 is not a prime number. 2 is the first prime number by definition. Okay. What's the probability of odd and prime?
2 over 6.
Yeah, which ones are those? That would be what? Those would be 3 and 5, right? So that would be what? That'd be 2 out of 6. Okay, so the grand total of this thing is going to be 3 out of 6 plus 3 out of 6 minus 2 out of 6. So that's... Oh, it's also 2/3? Another example, that's 2/3? Oh, I didn't mean for that to happen, sorry. Also 2/3 is another example.